Okay, so today we're going to be talking about graphing rational functions. We're going to graph a couple of different forms. But these are pretty simple ones. They can get a lot more complicated, but we're going to start with the simple ones. So again, you guys will remember that a rational function is just when I have two polynomials that make a fraction, a polynomial on top and a polynomial on the bottom. And so when I graph it, it comes out to be what we call a hyperbola. A hyperbola has two symmetrical parts that are called branches. Okay, so we've got a polynomial divided by a polynomial. That's a rational function. Because again, rational, remember, it comes from the word ratio, right? And the graph is going to be a hyperbola. So my basic graph, the parent function is just 1 over x. And so my vertical asymptote is x equals 0, or the y-axis, and my horizontal asymptote is y equals 0, or the x-axis. The domain is all non-zero real numbers. The range is all non-zero real numbers. So why do you guys suppose that x can't equal 0? Because you can't divide by 0, right? We can't have a 0 in the denominator. So that's why x can't equal 0. Any thoughts on why y is never going to equal 0? In essence, yeah, if I have 1, there's no number I can divide it by to make it equal 0. It's going to be approaching 0. Like if I have 1 divided by 1,000,000, it's going to be a really small number. But if I go out towards infinity, is it ever going to get all the way to 0? No, it's just going to get smaller and smaller and smaller. Okay, so that's your parent graph. So we're going to graph y equals 6 over x, and then we're going to compare it with y equals 1 over x. So I'm going to make myself a table. So since the x is on the bottom, I just want to pick numbers that are easy to divide into 6. And so obviously -6 goes in, -3, -2, and -1. And then their positive counterparts, 1, 2, 3, and 6. So if I plug in -6, what am I going to get? -6 divided by -6 is -1. 6 divided by -3 is -2. 6 divided by -2 is -3. 6 divided by -1, -6. And then when we divide by the positives, we get positive numbers. Okay, so I have those points, and then I just plot them. So -6, -1, -3, -2, -2, -3, and -1, -6. So if I hadn't put any negative numbers into my table, I would be missing this whole side of the graph. So you want to make sure you have points on either side of the center of the graph. All right, and then finish plotting it. 1, 6, 2, 3, 3, 2, and 6, 1. Okay, I'm going to go ahead and make a table for y equals 1 over x also, since we didn't do that before. And so 1 is the only thing that goes into it evenly, so we're obviously going to have to deal with some fractions on this one. So I am going to put in a -2, a -1, and I'll go ahead and put in -1/2 also, and then +1/2, +1, and +2. So if I do 1 divided by -2, I just get -1/2, right? And 1 divided by -1, I get -1. If I do 1 divided by -1/2, that actually comes out to -2, because you have to flip over the bottom, right? And then divided by 1/2, I get +2. Divided by 1, I get 1. And then divided by 2, I get 1/2. So if I plot those points, -2, -1/2, -1, -1. Okay. So if I compare those two graphs, how does the purple graph compare to the green graph? It's wider or kind of stretched out, right? Is wider, stretched. And then you could also say that it is further from the origin, right? Just, that's all kind of saying the same thing, but. So as the number on top gets larger, it's going to kind of move away from the origin. Okay, so now we're going to talk about graphing translations. If the rational function is given to you in this form, y equals a over x minus h, and then plus k off by itself, then you can graph it using your hk as your origin, like we've done with other types of graphs. So your asymptotes are just going to be that x is equal to h and y is equal to k, because we can't have our denominator equal to 0, right? So if we make that equal to 0, then we figure out what the vertical asymptote is, and then as x approaches infinity, y is going to approach k. So those will be your asymptotes. The domain, it's going to be all real numbers, except h now, instead of except 0. And the range is going to be all real numbers except k. All right, so if I'm going to graph y equals -4 over x plus 2 minus 1 and state the domain and range. So first I'll look at what my asymptotes are. I've got a horizontal asymptote. I'll just go ahead and a vertical asymptote, right? And I probably should have done those the other way around, because the vertical one is the x one. Okay, so my vertical asymptote is going to be x equals what? What can x not be equal to? -2, because that will make the denominator equal to 0. And then my horizontal asymptote is going to be y equals -1. Okay. And then domain and range. Domain is going to be all real numbers except -2. Range is going to be all real numbers except -1. So what I'm going to do to graph it, I'll go ahead and draw my asymptotes on there. So x equals -2 and y equals -1. Asymptotes are lines. They should be written as the equation of a line, so don't just write a number for an asymptote. You always have to write x equals the number or y equals the number, depending on which one it is, okay? All right, so what I'm going to do is I'm going to make a table for my parent graph. So my parent graph would just be y equals -4 over x, and I'll make a table for that. So again, thinking of things that will go easily into -4, I could do -4, -2, and -1, and then do +1, 2, and 4. And having like 3 points on each side of the center is a good rule of thumb that'll give you enough that you can plot the graph reasonably well. So you typically want to have about 6 points for these when you're graphing them. All right, so if I plug in the -4, -4 divided by -4 is +1, -4 divided by -2 is +2, and -4 divided by -1 is +4. And then I get -4, -2, and -1. And then I just plot the points. So negative. Now, when I plot the points, though, I pretend that that new point, that -2, 1, I pretend that that is my origin. And so I go back 4 from there and up 1. And then from that same point, I'll go back 2 and up 2. And back 1 and up 4. 1, 2, 3. Okay, so we're pretending like the point -2, -1 is our origin, just like we did when we did other translations. So that's that half of the graph. And then to plot the rest of it, out over 1 to the right, and then down 4, 2 to the right, and down 2, and then 4 to the right, and down 1. And there's your graph. Any questions? All right, so here's one for you guys to do on your whiteboards. So before you do anything, first show me what you have for your vertical asymptote and your horizontal asymptote. And remember, they're equations of lines. Okay, so some of you are just giving me numbers for the asymptotes. Remember, it is a line, so I should have an equation. X equals 3, y equals 2. Not just 3 and 2, okay? All right, so what was our domain? Okay, x can't equal 3, and the range? Y can't equal 2, right? Yeah, and so if you want, you can write it that way, or you can write except 3, except 2, whichever you prefer. All right, so then if we plug in a -2, what do we get? -1/2, -1, -2, 2, 1, 1/2. So those are the points you should have had in your table. And then again, you just use this point, 3, 2, as if it was your origin. So go to the left 2 and down 1/2, and then -1, 1. So this side of the graph looks like that. And then over 1/2 up 2. There's the other side of the graph. So it should have looked something like that. Okay? Any questions on translating graphs? Okay. One more form I'm going to show you today. And that is if it's in the form ax plus b over cx plus d. So this one's not in our HK form. It's not easy to tell where it's being translated. But we still can figure out the asymptotes. And then we'll just make tables just using the actual equation. So my vertical asymptote always happens because my denominator cannot equal 0. That's the case whether it's in HK form or whether it's just a polynomial over a polynomial. You can always set the denominator equal to 0 and get your vertical asymptote. And so if I set cx plus d equal to 0 and solve it for x, subtract the d from both sides, and then I would divide it by the c, and so x would equal negative d over c. But if you don't remember that formula, what can you do? Just do it. Just set it equal to 0 and figure out what it comes out to, okay? Now, when we're talking about the horizontal asymptote, we're thinking about what's happening as x approaches infinity. So as x goes to infinity, are b and d going to make much difference? Like if I have, let me just do a specific example. Suppose I have f of x equals 2x plus 1 over 3x plus 2. As I put in larger and larger numbers, are the 1 and 2 going to make much difference? They aren't, are they? I mean, if I'm going to have, like, if x was 1,000,000, I'd have, instead of 2,000,000, I'd have 2,000,001. Is that really a lot bigger when we're talking about millions? No. So what happens is that b and d become insignificant as x approaches infinity. So that means that when I'm figuring out my horizontal asymptote, I can essentially ignore them, okay? So I've got y equals ax plus b over cx plus d. B and D become insignificant, so I completely ignore them. I don't care about them. So now I've just got y equals ax over cx. If y is ax over cx, what else cancels out? The x's, right? And so finally you're just left with y equals a over c. And that ends up being your horizontal asymptote. So essentially you just look at the coefficients out in front of your x's. And that's going to be your horizontal asymptote, okay? All right, so as an example, we're going to graph y equals 2x plus 1 over x minus 3, and we're going to state the domain and range. So before I graph, I want to know what my asymptotes are. So I'll look at my vertical asymptote and my horizontal asymptote. And then we'll also do domain and range. Okay, so for my vertical asymptote, that means x minus 3 would have to be equal to 0. So what would x be? Positive 3. So x equals 3 is my vertical asymptote. And as x approaches infinity, these become insignificant. My x's cancel out. What am I left with? 2 over 1, or just 2. So y equals 2 is my horizontal asymptote. And so then that helps me figure out my domain and range. My domain is going to be all real numbers except 3. My range is going to be all real numbers except 2. Now, because this isn't in an HK form, I can't really do a parent graph. I'm just going to actually use this whole thing to make my table. So let me go ahead and graph my asymptotes so I don't forget about them. So x equals positive 3 and y equals positive 2. All right, so I want to be able to make sure I get the left and the right side of the graph. So when you're choosing your data points for your table, I need to pick some that are on the left side of x equals 3 and some that are on the right side of x equals 3. So I'm going to choose 0, 1, and 2 on the left side of that, and then 4, 5, and 6 on the right side. So then it's just a matter of plugging in those numbers. So 2 times 0 is 0, so I have 0 plus 1 over 0 minus 3. That's just negative 1/3 or negative 0.3. And if I plug in a 1, I'm going to have 2 plus 1 over 1 minus 3. So that's 3 over negative 2. So negative 3 halves, or negative 1 1/2. And so on. Plugging in a 2, I get 4 plus 1 over 2 minus 3. So that comes out to negative 5. When I plug in the 4, I get 9. When I plug in the 5, I get 5.5. And when I plug in the 6, I get 4 1/3, so we'll just say 4.3. So you're just plugging it into that equation, the whole equation. That's why I highlighted the entire equation. We're figuring it out for each individual point. And we're just going to use our regular origin when we're plotting the points. I'm not going to pretend that the origin's anywhere else, because this isn't HK form. So I'm not translating a parent graph. I'm just graphing exactly what I have here, okay? So I go to 0 and negative 0.3, 1, negative 1 1/2, 2, negative 5. So there's that half of the graph. And then if I plug in 4, I got 9. So 4, 9. 5, 5 1/2, and 6, 4.3. And so there's the other side of the graph. So see, if I hadn't chosen any points that were larger than 3, I would have been missing the whole right side of my graph. Alrighty, so here's one for you guys to do. Why don't you, again, same thing, show me your vertical asymptote and horizontal asymptote before you get too far, so you know that you're at least starting off right. All right, so it looks like most of you are getting the same thing. X equals negative 3, right, for my vertical one, and y equals 1 for the horizontal one. Okay, so when you plugged in negative 6, negative 5, negative 4, negative 2, negative 1, 0, you would have gotten the points. It looked like that. All right, I've got one more thing for you guys to do. We still have 3 minutes of class. Okay, now I'm not going to ask you to graph it, but I want to know the vertical asymptote and the horizontal asymptote. So on your whiteboards, show me what the asymptotes are. And heck, give me your domain and range too. All right, so vertical asymptote. We put 4x minus 2 equal to 0, and we got that x was equal to 1/2. And then for the horizontal one, all of this becomes insignificant. 2 over 4 also reduces to 1/2. So my domain and range are identical, aren't they? All real numbers except 1/2. Okay. Any questions on what we covered today? All right, that's it for today.